Hi Kai, this is a video for you to work through some of the problems on the arithmetic Accuplacer review problems that you sent me in your text. Before I get into the specifics, I just wanted to point out, in this packet that I sent you, you notice that there's more than just the math questions. The three sections of math are kind of buried in the middle of this. And I decided to include the other sections because I believe, correct me if I'm wrong, but I believe this is your first time to sit for the Accuplacer. So they're going to test you, they're going to test you for an English placement as well as a math placement. Some of the way that they test for English may have changed. This is a fairly old review packet. It's from 2016, so that's like 6 years old already. I use it because the math problems haven't changed dramatically, but you might want to check online and see. But you'll notice there's a section called sentence skills. That's one that you would take. And then there's another one, the right placer, I believe you would take. That's where you actually like write a little essay. But then it switches into the math, yes. And then at the end, there's a section or two that does not apply to you. It's for non-native English speakers, ESL language use. So you would not have to take that one. So you might want to look into that, or maybe even ask your mom to look into it. What else is going to be on this Accuplacer besides the math? And you might want to do a little review on that as well. But that's my PSA to you, to be prepared on all of it. We're going into the arithmetic section. The names have changed, but the idea is the same. This is the basic stuff that they want to make sure that you're really strong on. It's the fractions, decimals, and percents. And if you can't test strongly in this area, they're not even going to give you the harder problems to see how you do on the algebra. So make sure that you feel really strong and confident in the arithmetic. And I know this is annoying. I know it's so annoying, but we're going to keep taking these review problems. You're going to keep going through them until you can get them right every time. Because there's no guarantee that these are the exact kinds of problems that are going to be on the test. So we want to make sure that if they do have one of these problems come up, you can just kill it. I mean, I don't mean that violently, but you can be extremely successful at it because there may be some surprises of problems that aren't in the packet. And so we want to make sure that you have all of these problems that you've had a chance to practice, you have them mastered completely so that you'll get those right. And hopefully you'll get most of the other ones right as well. But this is where we just want to make sure you're super strong and you understand all of these problems. So I'm flipping ahead to the ones, and again, let me remind you, this first section is the easiest section. So we want to master it. You had questions, your first question, let me just write it down here so I don't remember. It was 8. Oh, I wrote 19, but it was just 9, wasn't it? Yeah, 8, 9, 13. 14 was the one you said that you'd figured out for yourself, but I'll take a quick look at it. And then 20. Those were the 5 that you sent me. So let's dive in. 8. This is the kind of problem that gives students a headache because when you look at it, it's got a big long paragraph of words. Ugh. All right. I don't like them either. Nobody does, because we have to translate the problem from math into numbers and symbols and then do the math. So that's why these problems are so exhausting, is because it's 2 steps of decoding. So let's figure what's out happening here. There are 3 people who work full-time and are to work together on a project, but their total time, sorry, I have to yawn. See, it's putting me to sleep already. Blah, 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 blah. That's what my head hears. I have to force myself to think about it. Their total time on the project is to be equivalent to that of only 1 person working full time. Okay, so what immediately jumps into my mind is that they're working each less than 1 person, which means fractions, and I can see just glancing at it, oh yeah, there's fractions. And they're gonna have to add up to 1 because that's what we're only allowed 1 person's job. If one of the people is budgeted for half of his time to the project and a second for 1/3 of her time, what part of the third person's time should be budgeted to this project? Okay, this is not easy, but what we can do is say, okay, the first person's working half time. The second person's working third time. The third person is working some fraction and we don't know what it is, so we're just gonna toss an X in there. And that all has to add up to just one person. Okay, so these are the fractional parts and they have to add up to one. We don't know this fractional part, but now that we have taken this problem and created an equation for it, we can now do the math around it. These problems are really common because they're so confusing, and so I really encourage you to keep puzzling over this one until it starts to make a little bit of sense. But it's kind of like job sharing, right? I don't know if you know people who job share. There's a pair of twins who live in my neighborhood that are roughly my age. They're identical twins, and for a long time they job shared at the reception desk at the YMCA in Mukilteo. So it's kind of funny because they job shared, but it always looked like the same person. But they each work 1/2, and that added up to one whole person. One identical twin. So that's kind of, if you can think of it as like job sharing, if that's something that's easier for you to understand, rather than this whole project thing, that might help you. Okay, so now what we have to do is say, okay, we figured out how to write this. This is an equation. Now we solve it. Okay, we can see that we're gonna have to do a little bit of algebra work here, but that's okay. That doesn't make us panic. The first thing we wanna do is take note of the fact that we're working with fractions. We're adding fractions, and so that means the denominators have to match, which means we have to come up with a least common multiple or least common denominator, two different ways of saying the same thing, that is going to allow us to bring 2 and 3 together. Well, I know that's gonna be 6, right? That's the lowest number that both of those guys go into. So we're gonna have to adjust both of them. I'm gonna use another pen color to do that. In order to get this first fraction to be a 6 on the bottom, we're gonna have to multiply it by 3/3, right? That's equal to 1, so we're allowed to do that. And this one, to get this 3 to turn into a 6, we're gonna have to multiply it by 2/2. And this is kind of almost like so easy, it's silly to write it down, but this 1, we're gonna change to 6/6. We're essentially multiplying it by 6/6. Okay, so now let's do the multiplications. We'll have 3 times 1, that's 3 over 3 times 2 is 6. And this makes sense because 1/2 is 3/6, that's cool. Plus, this will be 2/6, and we can see, yeah, that's equal to 1/3. We can do that in our heads. Oh wait, plus x equals 6/6. Okay, so now we've got this, so the fractions all look good. Now we're gonna combine like terms right here, and this will become 5/6 plus x equals 6/6. And then we will just isolate the x by subtracting this 5/6. That's gone, x is by itself, and we get x equals 1/6. We look for an answer. It's probably too hard for you to see, but that is B. It's always a good feeling when you look and you find your answer. It's always a terrible feeling when you look and it's like, it's not there. Okay, and let me check. Problem 8 is B. Yay, we got the first one right. All right, so that's the situation with 8. That's a challenging problem. Okay, number 9. Did I record all that with my phone crooked? Because it looks really crooked. I'm gonna hope that it was all right. And if I did that whole problem with the phone crooked, sorry. This is a low-tech operation. 32 is 40% of what number? 32 is 40% of what number? I'm abbreviating there. All right, this is a kind of problem that John Saxon loves. We did a million of these, man. I wish you had been with me all through the years because you would just be like, oh, I've got this one. But I'm not gonna teach you that method because it'll just be confusing because it's got a whole backstory that's weird. So, never mind. Imagine that one of your siblings, I'm gonna say Jackson, comes to you with a bowl of 32, I don't know, whatever your favorite candy is. I'll say peanut M&Ms because I had some of those tonight. 32 peanut M&Ms. And you say, what? Is this all I get? And he says, well, you got 40% of the bag. And you want to know, well, how many were in the bag, right? If there was some total number and I got 40% of them and you're telling me that it was 32, I want to know how many were in the whole bag. So this is how we write that out. 40% we write as 40 over 100 because percents are always over 100. 40% times whatever that number that was the total in the bag. I'm just going to write down here, total bag. And that's what this number is too, in our little scenario here. So 40% of whatever that number was, your brother is telling you was your share, which is 32. I don't know why you got 40% of the bag. That seems, in a family with 4 kids, that seems like a very generous share, but I don't know, maybe it's just between you and Jackson and he's taking 60%. I don't even know, you better watch him. Okay, so this is how we set it up. This is the percent, this is the number in the whole bag, and this is your 40% share. So what we can do is the algebra on this now to calculate what number of peanut M&Ms, or whatever you like, is in the total bag. So we need to isolate this. The best way to isolate a variable when we're multiplying it by a fraction is to use a reciprocal. Flip that little puppy, right? We're going to multiply both sides by the reciprocal because that's how algebra works. I'm going to put that over a 1 just so it doesn't look weird. This is all going to cancel, isn't it? Because the 40s cancels and the 100s cancel. Now the x is by itself. Now all we have to do is simplify here and we'll have our answer. All right, the first thing I'm going to do is essentially divide top and bottom by 10. And I can do that just by crossing out the 0, but I had one student who thought you could just cross out zeros randomly. That's not what I'm doing. I'm dividing by 10, and I'm just showing it by crossing it out. Okay, now I'm gonna say how many times does 4 go into 32? I got that, it's 8. So this is gonna cancel all the way out. This is gonna cancel and become an 8. This would be a 1, technically. And then 8 times 10 tells me that x equals 80. So there were 80 peanut M&Ms in the whole bag. Your brother counted them out. He put his sweaty little fingers on every single one of them and counted out 40%, which is 32. 40% of 80 is 32. That's what we just proved. Here's our answer. 9, that would be C. And there it is, 9C. Yay, we got 2 right. Okay, what's the next one, 13? Yeah, I better check and see if I wiggled my book again. Okay, we're all right. 3 of 4 numbers have a sum of 22. If the average of the 4 numbers is 8, what is the 4th number? Okay, I have a very specific way of doing these that I've never seen in a textbook, but I think it makes the most sense. We're finding the average of some numbers, 4 numbers. In order, but instead of calculating the average, they're giving us some of the answers and making us work backwards and figure it out. So what I like to do is draw a picture of how I know we calculate averages. If you have 4 numbers, you write them down. I'm not going to use letters. I'm going to use like empty boxes because I don't want letters freaking us out and all of this. You would have 4 numbers. You would add them all up and you would get a total. Then to find the average, you would divide that total by the number of numbers, if that doesn't blow your mind. 1, 2, 3, 4 in our example. We would divide it by 4 and then that answer would be our average. Now, I've never seen anybody do this, but this is the way our brains flow through the calculation of an average, right? In this example, it's 4 numbers. We add them up, we get a total. We divide by 4 because it's 4 numbers. We have our average. Now, once we lay out this like template, we're gonna take what we're being told in the problem and we're gonna fill it in and see what we can figure out from that. 3 of the 4 numbers have a sum of 22. So I'm gonna show it like this. Here's 3 of the 4 numbers, right? 1, 2, 3. They have a sum of 22. The average of the 4 numbers is 8. Okay, not the total, but the average of the 4 numbers is 8. What is the 4th number? So that's what we're supposed to find. Okay, it's kind of a hodgepodge, isn't it? So, but what we're gonna do, anytime we get a problem like this where they tell us the average, we're gonna work backwards. If the average is 8, then we know that if we take 8 and multiply it by 4, we'll get the number that was here. 8 times 4 is 32. So we added up these numbers. We must have gotten 32 because when we divide by 4, we get the 8 that the problem tells us is what we got. So what that means is that these 4 numbers must add up to 32. We already can account that the first 3 numbers add up to 22. So this must be 10. And that is answer D. Does that make sense? Create the little template and then work backwards to plug in what you know and then figure out how to do the rest. Let's check and see if that's right. 13 is D. Did I write that? Yes, it's a D. Yay! Okay, it's very exciting, isn't it? You know, I understand why students get frustrated with math and don't always love it, but come on, that feeling when you get it right is so good. I love that. Okay, 14. You said you thought you could figure this out, but I just want to take a quick look at it because it's important and I want you to feel rock solid and not kind of okay. All right. It is scientific notation. I love scientific notation because it's like writing in code. And I don't know if you and your siblings ever played detective when you were little kids, but I did and my kids did. So maybe you did, but I don't know, maybe you and Jackson were just sword fighting the whole time and you never stopped. But this is a code. This is a number that we're gonna change a little bit by a power of 10. The exponent tells us 2 things. It tells us how many jumps we should give the decimal in the number, how many times we're jump it, and this tells us to make the number either bigger or smaller. If we have a positive exponent, that tells us to make the number bigger, and if we have a negative exponent, it tells us to make the number smaller. Now, some teachers teach this in terms of right and left. I find that hopelessly confusing. I can figure out myself which way to move the decimal if you tell me bigger or smaller. This is enough to know. So I see this -2 and I say, okay, what the code is telling me is take this decimal and move it 2 jumps that will make the number smaller. If I move the decimal this way, it's gonna make it 4,620. That number is bigger than 46. So that's not the way I wanna move. I wanna move it this way because that's gonna make my new number smaller than 46, right? Because what I'm saying is that it's gonna be 0.462. If you like, you can put a 0 in there, not necessary. This is the decoded number after I take it out of scientific notation and write it back. 14, 0.462, that is B. Let's look and see if I did it right. Ready? 14B. Happy days. There it is. All right. Okay, so you probably figured out, oh, I moved it the wrong way, so I guess I just moved it the other way. But I want you to understand, a negative exponent means, the code meaning of that is make the number smaller than it is now. And if it's a positive number, which, you know, it would just be the number, it wouldn't be a plus sign. That means make the number bigger than it is now. So we would make the number bigger. Okay, one more. Number, what was it? 20. Really paranoid about my pages being out now. 20. All right, another long chunk of text. I know, it's annoying. Jen wants to tile the floor of her kitchen. The floor is rectangular and measures 12 feet by 8 feet. She's lucky that she has such a perfect, like her numbers come out whole. Okay, so I'm gonna draw, before we go any farther, I'm gonna draw a little picture of her floor. It always helps me to draw a picture because then I can kind of organize my ideas and see what's going on in my brain. The longer side is 12, the shorter side is 8. P.S. I think it always helps to draw a picture, especially if you're flailing a little bit. Okay, so what that tells me is, oh, I can figure out the area of this kitchen floor. The area is length times width, right? That's an L. I don't just write a straight line because then it looks like a 1. Length times width. It doesn't really matter which is length and which is width. We just know we multiply them. It would be 12 times 8. So that would be 96 square feet, because these are feet. That's how big the area of her kitchen is. Now, there's more. If it cost $2.50 per square foot for the materials, what's the total cost of materials for tiling the kitchen floor? So what we have to do is we have to take the 96 feet, square feet that she has in her kitchen, and you know it's going to be, I'm not going to draw all the lines. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then I'll start drawing. I know I'm going to end up doing it because I just can't resist. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I did it. I drew 96 little squares. So, because they're 8 by 12, I think I counted right. So there's 96 little squares. Each tile is going to cost $2.50. So we multiply. 3, 45 and 3 is 48. Put the 0 here, 12, 18, 19. I don't know if you're used to doing hand calculations or using a calculator. Please use hand calculations as you study for this test because I'm pretty sure you can't use a calculator during the test. You can check me and call me if I'm wrong on that one, but I am pretty darn sure that you have to do hand calculations. So please practice doing hand calculations so your brain will be pumped for it. Okay, I'm gonna add. Okay, there's my answer. But remember when you multiply by a decimal, you have to put the decimal back in the answer. We see 1 digit behind a decimal place in the factors, so we just need 1 down there. So that means it's gonna cost us $240 to tile that kitchen. I have a feeling that this person hasn't been tile shopping in a long time. It's really cheap. Okay, number 20, that $240 is D. Put a nice box around it. Here's my answers. 20 is D. Yay! Got it right. Okay, there we go. So what I want you to do is I want you to go back, now that you've watched this video and seen how I've done it, now go outside and blow off some steam, do whatever you need to do. Come back to this in a couple hours and try these 5 problems again and see if you can get them correct. When you can get them correct, then you're ready to move on to the next section, which in this packet is called Elementary Algebra. In the other packets, okay, the low level has the same name, Arithmetic, right? That's the first one, and that's also the name of the first test in this other booklet I gave you. In this older booklet, it's called Elementary Algebra, but in this one, they call it Quantitative Reasoning, Algebra, and Statistics. Whatever, they're just trying to sound smart. And then the third section in this older booklet is called College Level Mathematics. And that is the same level of testing. They gave it a new name, Advanced Algebra and Functions. Don't let the names scare you. That's what I like about the old names. I think they're less terrifying. But those two different names match up to the same levels, okay? So that's just to help you see that the two go together. They just upgraded the names. Okay, once you get these 5 problems mastered, then you're cleared to go ahead and start on the elementary algebra, and we'll do the very same thing. You try it by yourself. Let me know which ones you got wrong. I'll send you a video. You'll practice the ones you'll practice those problems until you get them right, and then we'll move on again, all right? Text me after you watch this video and tell me it helped, it didn't help, or I don't even know what I'm doing anymore. I don't know. Just tell me how your brain works. Okay, that's all. Oh, look, I'm crooked again. Dang it. I was pounding on the table, that's why. I get very heated. Okay, I'm done. Goodbye.